Hello future toppers. So now we are going to start a new chapter which is electromagnetic induction. In the syllabus we have a few topics: magnetic flux, Faraday's laws of electromagnetic induction, Lenz's law and law of conservation of energy, expression for induced EMF based on both laws, self-induction and self-inductance, mutual induction and mutual inductance. So this is from the syllabus. One more thing which is the additional information which I'll just give in this particular session. This is the overall syllabus from this chapter. So in today's class, I want to cover all these topics in a one video. So let's begin. The magnetic flux. So students, magnetic flux is represented by the term phi, and magnetic flux through any surface is what? Is the number of field lines. Which field lines? Magnetic field lines passing normally through the surface. So if I'm just taking or assuming, let's say this is a magnetic field lines. If I'm sending these magnetic field lines through any particular surface, clear? So this magnetic field lines actually depends on the surface, actually the area of that surface. Secondly, is it magnetic field lines making an angle or not? Understood. So phi basically depends on the few factors like B, magnetic field, how much is the strength of magnetic field. Second, A, the area of the surface. Third, the angle of the magnetic field. That means a particular angle by which magnetic field actually tilts. So theta will be that factor. So we can say that it can also be defined as the product of the area of the surface and the component of magnetic field normal to that surface. So if I'm just talking about the normal to that surface, so this will be from the surface, normal to that surface, so this will be cos theta. That means phi is equals to vector B dot vector A is equals to BA cos theta. This is a diagram for this. So when the magnetic field line is passing perpendicular to that of particular surface, and if the surface is actually which we have taken is a tilt, so that will be makes an angle theta, and the component which rises, that will be cos theta. Next topic is flux linkage. So if the coil has a more number of turns or more than one turns, then the flux through the whole coil is the sum of the fluxes through the individual turns. That means if the magnetic field is uniform, the flux in one turn is phi is equals to BA cos theta. If the coil has n turns, capital N turns, so the total flux linkage phi is equals to NBA cos theta. If I'm just talking about the most important points related with this particular thing, so magnetic flux is a scalar quantity. Earlier we studied these things. SI unit of magnetic flux is Weber or Tesla meter square. So these two basically units which we are using mostly in the numerical part. Okay. CGS unit of magnetic flux is a Maxwell, and 1 Maxwell is equals to 10 to the power minus 8 Weber. Dimensional formula. If I'm just talking about what is the dimensional formula about this? So the phi is equals to BA. The value of B is equals to like F by IL. F is nothing but a force, and I is a current, and L is the length. So here, like if I'm just putting all these values, so this value came into the existence. Now magnetic flux associated normally per unit area is called magnetic flux density. Again, this is a very important point, like for for 2023 examination for the board, magnetic flux per unit area is called magnetic flux density or strength of a magnetic field or magnetic induction. these are few points which is really important topics. Like 1 marks question direct arises from these particular topics. So keep these things into the mind. Magnetic flux across a coil can be changed by charging. Now, the how this will be changed, like a strength of magnetic field, if the value of V changed, area of the cross section A changed, the orientation of the coil with the magnetic field theta is 0. Theta or anything will be 0, like 180. So that will be depending on the orientation of the coil. Any of the combination of above. If any combination will be matched out, that means this is the actual flux which you will be get. Next topic you have Faraday's law of electromagnetic induction. The first law is satisfied or explains that whenever there is a change in magnetic flux linked with a circuit, an EMF, and hence a current is induced in the circuit. However, it lasts only so long as the magnetic flux is changing. Second law, the magnitude of the induced EMF is directly proportional to the rate of change of magnetic flux linked with the circuit. That is, E is proportional to d phi by dt. What is the phi here? Yes, that is the electrostatic flux. So if I'm just like remove this proportionality constant, there will be a constant came into the nature which we were saying that proportionality constant. Here I suppose this constant will be as a K. Now, if the value of a K is equals to 1, we get the value of d phi by dt. Now, simply, if I'm just taking a changement which is at the macroscopic process, so that time, like we can take d phi as a phi 2 minus phi 1. So we just put this value over there and get the value of E. So if I'm just talking about the main core detail, that is the K is a constant and unit are chosen such that K is equals to 1. Moving ahead, Lenz's laws. The direction of the induced EMF or induced current is such that it opposes the change that is producing it. That means if the current is induced due to the motion of the magnet, then the induced current in the coil sets itself to stop the motion of the magnet. If the current is introduced or induced due to the change of in the current in the primary coil, I'm talking about this, then induced current is such that it tends to stop the change. What is the meaning of these two statements? Simple mean is that if I'm just try to like induce a particular current, so that current will be by which actually they are by the source by which they are actually radiated, they start to oppose that source current. This is actually Lenz's law. So expression for induced EMF based on the both the laws, E is equals to minus d phi by dt. That means minus phi 2 minus phi 1 divided by t. And n is number of turns of the coil. So E is equals to minus n d phi by dt. I've just put all these value over there. If you have any doubts, so you can ask in the chat session. So here the number of return is equals to n. So I just put the n term here. Expression for the induced current. So I is equals to, we know that E by R. Or here I want to write E is equals to VR. Sorry. I is equals to V is equals to IR. So here V is what in the form of E. So E is equals to IR. We have to calculate the value of E. So so this will be E by R. Now if I just put the value of E, so this will be N phi 2 minus phi 1, which is this nature comes. So this is the expression in terms of a charge also. Like dq by dt is equals to minus d phi by r dt. So dq is equals to minus d phi by r. This is a very important formula for the board examination as well as the board student. So let's move ahead. Next topic will be the loop PQRS is slided into uniform and perpendicular magnetic field. The change increase in the area of the coil under the influence of the field is dA in time dt. This causes an increase in magnetic flux d phi. As you can see students, this is a uniform magnetic field and the direction of magnetic field will be inward. For that case, if I'm just taking a rectangular loop which is have a one end, that end is moving with the velocity v. The rectangular sheet have a length L. This section have a distance actually v dt. We can calculate the value of v dt like distance is equals to speed into time. So here the speed by which the particle is actually moving, that is a v. And the time which is I have taken for the small section of a displacement, that is a dt. So for that scenario, d phi is equals to vdA, which we know, and area is equals to length into breadth. And here we have just taken length, and instead of a breadth we have taken vdt. E is equals to, we know d phi by dt is already, and if I just put this value of phi over there, d phi, so we get the value of a BLV in a minus. For a little bit different derivation, I'll just do it here. V is equals to minus d phi minus, I'll just put it there BLV dt by dt. So this will be eliminated and the result will become minus BLV. The induced EMF is due to the motion of loop, and so it is called motional EMF. If the loop is pulled out, the magnetic field, then E is equals to BLV. The direction of induced current is anti-clockwise in the loop, that is a PSR QP by the Fleming right-hand rule. This is the actually Lenz rule. Explanation for the direction of induced current. According to the Lenz rule, the direction of induced current is such that it opposes the cause of changing magnetic flux. Here, the cause of changing magnetic flux is due to the motion of the loop. An increase in the area of the coil in the uniform magnetic field, therefore, the motion of the loop is to be opposed. So, the current is setting itself such that Fleming left-hand rule, the conductor's arm PS experience a force to the right, whereas the loop is trying to move to the left. Note that this against the force mechanical work is done, which is converted into the electrical energy. If the loop is completely inside the boundary, the magnetic field, then there will not be any change in the magnetic flux. And so, there will be not be induced any current in the loop. Fleming's right-hand rule. So, if I'm just taking a right hand, this will be showing that index finger will be showing the direction of magnetic field. The thumb will be showing the direction of force and the middle finger showing the direction of a current. That means if the central finger, that is a force finger, and thumb of the right hand stretched manually perpendicular to each other, so the four fingers point the magnetic field. Thumb points the direction of motion, that is a force. Then the central finger points the direction of induced current in the conductor. By changing the orientation of the coil theta in the magnetic field, so magnetic flux phi can be changed by changing the relative orientation of the loop. Because the theta is dependent on the magnetic field, that is a B. So with the magnetic field and hence EMF can induced in the circuit, like phi is equals to NBA cos theta. At time t, the angular velocity omega, theta is equals to omega t and phi is equals to NBA cos omega t. So differentiating with respect to time, d phi by dt is equals to minus NBA omega sin omega t. E is equals to minus d phi by dt. So E is equals to minus NBA omega sin omega t. What we did, we just differentiate this term. And the value E naught sin omega comes in the nature. The value of E naught is the NBA omega. This is a maximum EMF. The EMF changes continuously in the magnitude and periodically in the direction with respect to time, giving rise to alternating EMF. If the initial position of the coil is taken as 0 degree, that is the normal to the coil is at 90 degree with the magnetic field, then theta becomes theta plus pi by 2 or omega plus pi by 2, where E is equals to E naught cos omega t. So alternating EMF and consequently alternating current can be expressed in the sine or cos function. So here is the diagram for that. Like the method of inducing EMS is basically the use is the principle of a generator. So this is the value of a time period which we are taking as a factor theta, which is omega t. Angular displacement we can also take in the diagram of phasor diagram. In the case of a time period, this will be t by 4, 2t. This is the axis which is representing the EMF and this is the time. So as you can see over there, how EMF is changing with respect to time over there. This is a sinusoidal graph. If I just take the graph for the cos, so the cos graph starts from this section. Because the value of a cos 0 is 1. Like this. For the cos graph, we get this value. Because cos 90, the value of a cos 90 will be 0. So this is a cos graph and this is the sine. Like this. So this is the cos and this is a, or we can see this, the upper one is a sine graph and the lower one is a cosine graph. Self-induction. Self-induction is the phenomena of inducing EMF in the self-coil due to the change in the current and hence the change in the magnetic flux in the coil. The induced EMF opposes the growth or decay of the current in the coil and hence delay the current to acquire the maximum value. Self-inductance or self-induction is also called as inertia of electricity because it opposes the growth or decay of the current. This is a main property of the self-inductance. So here as we saw that it will be opposes the growth and decay of the current. The next is self-inductance. So this is a formulation only. The phi is proportional to I. When the proportionality sign removes the constant kinks in the nature, that is called self-inductance. If the value of a current I is equals to 1, then L is equals to 5. For that case, we can say that where L is the constant. So constant of a proportionality is known as self-inductance or coefficient of self-inductance. So the self-inductance is defined as the magnetic flux linked with the coil when unit current flows through it. The things which you have noted, the self-inductance is what is defined as the magnetic flux, as you can see over there in the formula 5. So this will be magnetic flux linked with the coil when the unit current pass through it. I hope you have understood the meaning of that. We know the formula of EMF, which is E is equals to minus d phi by dt. We just put this value over there and get the value of EMF E, which is a minus L di by dt. If the di by dt is equals to 1, then L is equals to E. The self-inductance is defined as the induced EMF set up in the coil through which rate of a change of a current is unity. The thing which you have to note, which is many times asked in the exam in the numerical also, the unit is given in the Henry. So the quantity will be, or the term will be, or the physical term will be denominated, that is self-inductance, Henry. Self-inductance is said to be 1 Henry when 1 ampere current is in the coil linked flux of 1 Weber. So self-inductance is said to be 1 Henry when unit rate of a change of a current 1 ampere per second induced EMF of 1 volt in the coil. Self-inductance of the solenoid. So this is a solenoid, as we saw earlier. If they have L length and the current A passes through it, the value of a current I and the cross-sectional area will be section this A. Magnetic field due to the solenoid is B is equals to mu naught N times I. Magnetic flux linked across one turn of the coil is pi per turn PA. We just put this value of B, mu naught NIA. So this will becomes mu naught NIA divided by 1. Flux linked across the n turns of the coil is like phi is equals to mu naught N square IA. So what I did, we just put this value mu naught IA over there and divide by dt. So we just put again the value of L over there. Pi is equals to Li. So L is equals to mu naught N square A divided by L. If we just put this value, so the value comes mu naught N square AL. Energy of inductor or energy in inductor. Small work done dW is stabilizing a conductor or the current I in the coil in time dt is dW is equals to minus E I dt. W is equals to L di with the I. E is equals to minus L di by dt. We just put this value and do integrate because here is a symbol of a differentiation. If we remove this differentiation we use basically for the small changement. For what we are starting to use? We are using this for a small changement. So when with this differentiation sign remove, integration comes in the nature. So after applying the integration symbol from 0 to I naught, we just give this value half L I naught square. Mutual inductance or mutual induction. So first topic, mutual inductance. Mutual induction is a phenomena of inducing EMF in the secondary coil due to the change in the current in the primary coil and hence the change in magnetic flux in the secondary coil. Mutual inductance phi 2a proportional to I1. Phi 21 is equals to MI1, where M is the constant of proportionality and I, and it is known as a mutual inductance or coefficient of mutual induction. If I1 is equals to 1, then M is equals to phi. Thus, mutual inductance is defined as a magnetic flux linked with the secondary coil when unit current flows through it, primary coil. Also, E2 is equals to minus d phi by dt. So E2 is equals to minus m di1 by dt. If the value of a di1 by dt is equals to 1, then M is equals to E. Thus, mutual inductance is defined as the induced EMF set up in the secondary coil when the rate of change of a current in the primary coil is a unity. Think which we have a note. SI unit of a mutual inductance is a Henry, and the mutual inductance is said to be 1 Henry, 1 ampere current in the primary coil linked magnetic flux of 1 Weber across the secondary coil, or mutual inductance is said to be 1 Henry, 1 unit or unit rate of a change of a current, that is a 1 ampere per second in primary coil induced EMF of a 1 volt in the secondary coil. Mutual inductance of a two long coaxial solenoids. This is a very important topic for your board examination also. So if we have just taken two types of a coil and they are just overlapped to each other. So for that scenario, like if they will be connected to the galvanometer and the length of the section will be L, here the section will be A and the I1 current will be passes through it. So magnetic field due to the primary solenoid is P1 is equals to mu naught N1 I1. Magnetic flux linked across one turn of the secondary solenoid is phi 21 per turn V1A. The flux of the second changes because of the magnetic field of the field 1 or the coil 1. So phi 21 is equals to mu naught N1 I1A and mu naught N1 I1A divided by 1. So here this value comes magnetic flux linked across n turns of the secondary coil is phi 21 mu naught N1 N2 I1 A by L. So phi 21 is equals to M21 I1. M21 is equals to mu naught N1 N2 A by L, or we can say that mu naught N1 N2 AL. Similarly, we can calculate the same value. Therefore, for two axial or coaxial means whose axis is 1 or similar. So, solenoid of the same length and cross-sectional area, the mutual inductance is same as the lead to the principle of a reciprocality or reciprocity. That means M is equals to M12 is equals to M21. Some important points we have to keep in mind because of the exam purpose. If the two solenoids are wound on a magnetic core of relative permeability mu r, then M is equals to mu naught mu r N1 N2 A by L. If solenoid S1 S2 have a number of turns N1 and N2, the different radii R1 and R2, and R1 is less than R2, then M is equals to mu naught mu r N1 N2 pi R1 square by L. Mutual inductance depends also on the relative placement of the solenoid. Coefficient of a coupling between two coils having self-inductance L1 and L2 and mutual inductance M. So K is equals to M under root L1 L2. Generally K is less than 1. So if L1 and L2 are in the series, we just add up together if they are parallel. So like a resistance, we just do this things like 1 by L is equals to 1 by L1 plus 1 more. In today's class, this one is the complete study of the electromagnetic induction. If you have any doubt, you can ask your doubt in your comment section, students. This complete electromagnetic video will help out to you in the board examination. I hope you like this video. Thank you for watching.